Dobry večer. Just Czechoslovakian for good evening. This is Mr. Begajski here. We're starting chapter 5. We are proving lines are parallel. So before our break here, we learned the angle names, meaning we learned corresponding angles, we learned consecutive interior angles, alternating interior angles, consecutive exterior angles, alternating exterior angles. So now we're going to take those ideas of knowing the types of angles, so if you don't, you really need to study them, and we're going to use them to prove lines are parallel. But before we get to that, we want to talk about the exterior angle theorem rule here. So angle 4 is an exterior angle to the triangle. Everybody sees a triangle here. 1, 2, and 3 are inside the triangle. Angle 4 is on the outside of the triangle. Our goal is to prove that 1 and 2 are the remote interior angles of the triangle. So 1 and 2 are the remote interior. Why is that? Because 3 and 4 right here, we know, are a linear pair and they're supplementary. Okay? So what we're going to learn is that the measure of the exterior angle of a triangle is greater than either of the remote interior angles. Okay, so this exterior angle is greater than either one of these two right here. Well, why is that? Because you actually learned something about an exterior angle. Okay, so these are the remote interior. Okay, they're the ones away from the exterior angle. And we know that this is a linear pair, so they're supplementary. So ultimately, what are we able to do? We're able to say that angle 3 plus angle 4 equals 180. We're also able to say, because we know this is a triangle, and in a triangle, how many degrees are there? Good, 180. So angle 1 plus angle 2 plus angle 3 is equal to 180. What do we notice? These both are equal to 180. So technically we can say that, hey, angle 3 plus angle 4 is equal to angle 1 plus angle 2 plus angle 3. And then we could even simplify that even more because they both have angle 3's on them. So we can say that angle 4, which is the exterior angle, is equal to angle 1 plus angle 2. And what is angle 1 plus angle 2? There's your remote interior angles. So this is the exterior angle theorem of a triangle, and that says that the exterior angle is equal to both remote interior angles added together. So the theorem here, where it says the measure of the exterior angle is greater than either of the remote interior angles, well, that has to be true because you need both of these two angles for it to equal that. Okay, so in this case, all we have to do is, because we know this angle has to be greater than the 50, we can say 5x minus 10 is greater than 50. Solve it. We get 5x is equal to 60, is greater than 60, divided by 5. X has to be greater than 12 for this to work. Okay, we'll get into more of the exterior angle theorem when we get into 7.1. Taking the idea of the angles, we're going to use our angle pair types and we're going to prove lines are parallel. So we're using these 6 theorems right here. I know it's a lot, but if you know the angle types, you know the theorem. So the long version says if two lines are cut by a transversal such that, so you have two lines that are cut by a transversal such that the alternating interior, so we'll call this 1 and 2, those are alternating interior. Alternating interior angles are congruent, so 1 and 2 are congruent. Then what do you know about lines A and B? Well, lines A and B both would have to be parallel. So basically what we're saying is if alternating interior angles are congruent, then we have parallel lines. You can do the same thing throughout. So we have alternating interior angles congruent, parallel lines. Alternating exterior angles congruent, parallel lines. Corresponding angles congruent, parallel lines. Consecutive interior angles, they're not congruent, they need to be supplementary. Remember, same side is supplementary. If you haven't been annoyed by that yet, hopefully you're getting there. So the same side supplementary, lines are parallel. Same side exterior supplementary, So they're parallel. And here's one. Let's star this one. So it says in a plane. So on a piece of paper, on the board, in the book, right? So in the 2 dimensions, in a plane, if 2 lines are perpendicular to a third line, then lines are parallel. So if 2 lines are perpendicular to a third line, the lines are parallel. So think about it. Here's 2 lines perpendicular to a third line. So it's perpendicular here and here. Oh, look at that. All the angles have to be 90. So basically you could use any one of these theorems to even prove this one. All right, here we go. Example 1. Example 1, we know angles 1 and 2 are congruent. We want to know which lines are parallel. Well, we talked about this in the last chapter, that angle 1 is created by AB and AC. Angle 2 is created by AC and CD. So if these two angles are congruent to each other, look at them. What kind of angles are they? They're alternating, and they're in between the parallel lines. So these are alternating interior angles. So that means AB has to be parallel to CD. And the reason for that is if alt interior angles congruent, then parallel lines. Awesome. Could BC and AD? Possibly. I just don't know that for sure. But they possibly could be. But we do know for a fact these two are because 1 and 2 were told that we were congruent. Number 2, solve for x. Okay, so we have to solve for x. We want to know, is M parallel to N? So right now, we don't know if these two lines are parallel. So we can't just pick angles to be congruent or angles like that. But what we do know is that these two angles right next to each other are a linear pair, so that means they are supplementary, meaning they equal 180. So we can set 2x minus 25 plus x minus 20 equal to 180. So we get 3x minus 45 equaling to 180. Add the 45 over. We get 3x is now equal to 225. We divide by 3, so x ends up equaling 75. All right, now we need to justify our answer, if these parallel or not. So we know this is x is 75. That would get you about a couple points, 2 out of the 3. But now are they parallel? Well, what do we know? We know that this angle and this angle would be alternating exterior. So to be alternating exterior, what does it say? Alternating exterior need to be congruent before lines are parallel. So if I put in the 75 here and I minus 20, what happens? 75 minus 20, I end up getting my answer of 55. Is that the same as this angle over here? So we can say that M is parallel to N because if alt exterior angles congruent, then parallel lines. Did we have to use alternate exterior? No. You could have said that this angle here and this angle here are consecutive exterior, but then they wouldn't have been congruent. What would they have been? They would have been supplementary, and then you would have been able to solve for that. Okay. You can't just assume that these two have to be congruent. You can set them equal to each other, because if you do that, you're going to do it wrong. So do not do it that way. Look for your linear pair or vertical angles of some sort. Moving on. Now to put it into proofs. There's not many sections of proofs in this area, but this is one of them. This is like one of the major areas of proofs for this. So we know that angles 3 and angle 1 are congruent to each other. We all know C is the center of the circle. So by now everybody knows this is going to create what? Good. Radii. So that means BC and CD are going to be congruent. We're trying to prove that BD is parallel to AE. So we're going to need to be using one of these 6 theorems right here. We need to get some type of angle pairs for that, okay? So let's see that. Here's BD. Here's AE. Well, there's 2 transversals, either here or here, but this is the one that has numbers marked, okay? Well, the only 2 angles on here are 3 and 2 that are on the transversal of AC. So what we do notice is that what kind of angles are 2 and 3? corresponding. What do corresponding angles need to be before the lines are parallel? Good, congruent. So if we can get angles 2 and 3 congruent, then we know that these lines are going to be parallel. Well, so we're not proving triangles here. Well, we would be starting with circle C. Reason 1, that would give us BC congruent to CD. Well, what kind of triangle did BCD make then if these two sides are congruent? Isosceles. So that means angle 1 would be congruent to angle 2 because if sides, then angles. We also know that from the diagram, angle 1 is congruent to angle 3 given. So wait a second. 1 is 2, but 1 is 3. So that means now that angle 2 is congruent to angle 3. And that's what we wanted because those are our corresponding angles. And we can finish with BD being parallel to AE. Reason 1, all radii congruent. Reason 2, if sides, then angles. 3, we'd use the transitive property. And 4, one of our new theorems up there, if corresponding angles congruent, then parallel lines. I do not want to see anything shorter than that. I gave it to you. You broke it down. You don't have to write in all those words, but corresponding angles congruent, then parallel lines. You missed the congruent part. You missed the then parallel at the end. It's going to be marked wrong for it. So this is what you're going to do. I can't tell you that you're going to prove triangles or you're not going to prove triangles with them because some you will, some you won't. You have to figure out, talk through it first before you actually start doing anything. And the last theorem here, the last theorem proves that idea up on top of saying that BCW, which is this angle here, which is the exterior angle, has to be greater than either one of the two remote interior angles. Okay, because what do we know? We know that AD is congruent to DP. BD is congruent to there. And we also know that angle 4 and 5 would be congruent because they're vertical. So we can prove that triangle ADB and DCP are going to be congruent because of that by side, angle, side. So let's do that. AD is congruent to DP. We know that from the diagram, reason 1, angle 4 is congruent to angle 5. And we also know that BD is congruent to DC. Put this all together. Reason 2, we have triangle ABD is congruent to triangle PD. No, sorry, PCD. Now those two are congruent. Now we can use our CPCTC step and say angle 2 is congruent to angle 3. But wait, 2 and 3 are congruent. I wanted to prove that this was bigger. But what do you know? You know that angle BCW is equal to angle 3 plus angle PCW, right? And if these two were equal, if 2 was equal to 3, what can I do? I can substitute in 2 here. And I just proved that BCW put my wall. So we learned that BCW is equal to angle 2 plus PCW, which means that the measure of BCW is greater than the measure of angle 2. Talk through it because what did you do? The first one was vertical angles congruent. 2, we proved the two triangles by side angle side. 3, obviously everybody knows CPCTC comes afterwards. 4, we brought back definition of congruent because we went from congruent to equals. All right. 5, what we did here, 5, we did substitution because there were equal signs. 6, then what we did was we subtracted, we removed the PCW, and we were able to, talk through it and say that these were there. So it does work. You've seen it in the theorem. You saw it up on top. Good luck to you on this lesson. 5.2, as long as you know your vocabulary and you know the angle pairs, you should be successful at this unit. Good night.